Hey, it's Mr. Estrada. In this video, our aim is to answer the question, how do we specify terms of a sequence given its recursive function? And in this video, you're going to learn about recursive sequences and how you specify the terms of a sequence when given its recursive definition. Okay, so first as a warm-up, I want you to consider the sequence here, 2, 5, 26, and 677. How do you see it growing? So if you want to pause the video and think about it for a second, go right ahead. Okay, so one of the things that you should notice is that the sequence here is neither arithmetic nor geometric because it's not growing by a common difference and it's not growing by a common ratio. So it's not arithmetic and it's not geometric. It does, however, have a pattern of development based upon the previous term. So what do I mean by that? So if you look at the first term, 2, if we take that first term, 2, then we square it, then we add 1, we get 5. So that's how we go from 2 to 5. But now we're going to take that previous term, that 5, and we're going to square that and then add 1, and we get 26. And now we're going to take that 26, square that, add 1, and we get 77. So it follows a pattern that's based on the previous term. So take 2, square it, add 1, you get 5. Take that 5, input it here, square it, add 1, you get 26. Take that 26, input it here, square it, add 1, you get 677. So based on this pattern, can you figure out what the fifth term, A5, should be? Go ahead and pause the video, think about it for a second. So if you think that it should be 458,330, you are correct. Because we have 677 squared, and that's going to give us 458,329, then add 1, and you get the term here. Okay, so what is recursion? Recursion is the process of choosing a starting term and repeatedly applying the same process to each term to arrive at the following term. Recursion requires that you know the value of the term immediately before the term you are trying to find. So let's look at an example with recursive sequences. But before we do that, let's actually talk about the recursive formula. So the recursive formula has two parts. It has a starting value, that's denoted A1, that's your first term. And then it has a recursion equation for AN as a function of AN minus 1. And AN minus 1 is just the term before it. So let's look at an example here. We're asked to write the first 4 terms of this recursive sequence. So here we have our first term, and here we have our recursive equation. And we're asked to find the first 4 terms. Okay, so the first one is -4. Okay, so now, what this recursive equation is telling us to do is, you see this AN minus 1 here? It's telling us to take the previous term and add 5. So to get A2, we have to take the previous term, -4, add 5, and we get 1. To get A3, we have to take the previous term, which is 1, and then add 5, and we get A3. To get A4, we have to take the previous term, add 5, and we get A4. So the first 4 terms are -4, 1, 6, and 11. Let's look at another example. So it says find the term of the recursive sequence defined below. So again, we have our beginning term here, and then we have our recursive equation, which is telling us to take the previous term, an minus 1, and multiply it by 3. So a1 is 3. To get a2, we take the previous term, which is 3, multiply that by 3, we get 9, so a2 is 9. To get a3, we take the previous term, which is 9, multiply that by 3, and we get 27. So the third term is 27. Let's look at our last example. Find the first 5 terms of the sequence. So we have our first term here, and we have our recursive equation here. So the first term is 3. And let's go ahead and find the second term. Okay, now notice something here. This says n. It doesn't say n minus 1. So in this case, to find the second term, n is 2. And then an minus 1, that's our previous term. Our previous term is 3. So we substitute that in there. So we're going to have negative 1 squared times 5 times 3. So 5 times 3 is 15. 15 times 1 is 15. So the second term is 15. To get the third term, remember over here it's n. In this case, to find the third term, n is 3. And then an minus 1, that's the previous term. The previous term is 15. So we have 15 times 5 multiplied by negative 1 to the third. Negative 1 to the third is negative 1. Negative 1 times 75 is negative 75. Okay, so now to find a4, we have to raise negative 1 to the 4th. So that's the n. Take the previous term here, multiply by 5, multiply by negative 1 to the 4th, which is going to give us a value of negative 1, and then negative 1 times 5 times negative 75 is negative 375. So repeat the same process to find the fifth term. So negative 1 raised to the 5th here, because that's n. Multiply the previous term by 5, and then multiply this by the result of this, and we get 1,875. So the first 5 terms are 3, 15, negative 75, negative 375, and 1,875. Okay, I hope this video helps. Take care.